This is Harshit, and this is a report of the second experiment of signal system lab, where the aim is waveform generation MATLAB GUI, where we will generate some elementary signal, periodic signals, and we will see signal addition, signal multiplication. The most important part is to get a MATLAB GUI to be the waveforms generated. Now let's move into the code. This is a MATLAB GUI. Most of the functions are automatically generated, and we create a new GUI. So these are our axes, these are our 2 buttons, and these are our 4 edit text, and these are pop-up menus. Moving on to this is our main function, which is automatically generated. This is our one more function, and this is a function for callback, function menu callback here. And this is a function for discrete button callback. This is a function for continuous button callback, and these are the function to take in input values. And we code to use to make, and we take the input using get handle. So start moving on to our GUI. First we will see the unit step function. The starting edge, let it be -5, and the ending edge, let it be 5, and we will see the continuous signal and discrete signal. Moving on to the code. Here we have a code for that, and is C is for continuous function and D for discrete function, which is passed through our GUI function. Here we declare vector t, and we create unit step equals to 1 for all positive values, and we plot that similarly, and we can see as a this is a continuous signal for that. Now we'll see a rectangular pulse function, and here we need to give amplitude, let it be 3, and time period, let it be 4. Here's a continuous signal, this is our discrete signal. Now we'll see the code for that. Yeah, here's the code for that. Similarly, CH is choice, which is C for continuous and D for discrete. A and B are intervals. A is amplitude and T is time period. Here we make use of rect pulse, which is a predefined function in MATLAB, and plot it. And similarly, we do for discrete time, it is sampling period of 1 second. Moving on to our next function, which is signal function. Here we don't have to give this value, so we can keep them empty or as they are, as they discard the values. Now this is a continuous function, and it's a discrete function. Moving on to our code. Here's a code for signal, and here we first make it all zeros for all t, and 1 for all positive, and -1 for all negative, and similarly we do for discrete time. Moving on to our next function, which is a ramp function. We similarly get the same values, and we get this function for continuous, and it is for discrete. We'll see the code for that. Yeah, here's the code. Similarly, ramp is 0 for all t less than 0, and equals to t for all positive values. And similarly, we do for discrete button using sampling period of 1 second. Now we'll see our next sinusoidal function, where 3 is the amplitude for the time period, and the starting and ending edge is our sine continuous function, and it's a discrete function. Now we'll see the code for that. Yeah, it's a very simple function where we make use of sine to plot the sine values using continuous for continuous time and discrete time using interval of sampling period of 1 second for discrete time. Moving on, the next function is exponential function, and also we give values and see the graph. It is for continuous time, it is for discrete time, and now we will see the function for that. Yeah, it is also from C into e to the power at, where a is positive for rising function and a is negative for decaying function, and similarly we make use of exp for exponential values and plot them for continuous time and discrete time. We can see if a is negative, that will give a decaying function. Yeah, let it be positive for our next function, which is complex sinusoidal function. Yeah, here it is a complex sinusoidal function. It is in 3D curve. Similarly for discrete time, we have this. We go to our code. Yeah, this is the code for that. Here we make use of standard definition, which is this, and we simply create a vector t, and I equals to square root of -1, which is plot for iota. Then y equals to, similarly we define that, and we use plot 3 for 3D curve and stem 3 for 3D discrete curve, and plot that similarly. Moving on to our next function, which is for exponential. We give the same values and see the curve. Now let me decrease the interval for better readability. Yeah, now you can see the better the shape of the curve, and similarly for this. Now we will see the code for that. Yeah, Here's a code for Cauchy exponential, where you can see exponential of x into unit of x. If we declare vector t, then Cauchy exponential is 0 for all t less than 0, and we use plot function and stem function to plot the curves. Moving on to the next function, which is impulse function. We see the impulse function now. It is 1 for 0. Let me do it 5 for better symmetry. Yeah, now for discrete. Let's see the impulse function. Yeah, it is a simple function which is 1 for only for t equals 0 and 0 otherwise. Similarly, we do for discrete time with the same bit of 1 second. Moving on, now we'll see periodic signals. First, the periodic total signal with the amplitude of 3 and time period of 4 seconds. These are discrete continuous signal, there's a discrete signal. Now we'll see the code for that. Yeah, here's the total function, where we make use of total, which is a predefined function in MATLAB, and we make use of that and plot it. And similarly, we do for discrete time. Now moving on, we will see a pulse waveform. Let the same values be same with the argument. Now we will see continuous signal and discrete signal. Now this is a function for that. Here we make use of pulse train, which creates a train of pulse for rectangular pulse function with a pulse width of t by 4 and pulse train similarly. And similarly we do for the discrete button also. Now we will see our periodic square waveform. Similarly, with the values is a square waveform and discrete waveform, and now we will see the code for that. Yeah, here's the code. This is a very simple function. We make use of square, which is a predefined function in MATLAB, and similarly we do for discrete time. We'll move on to our last function, which is a periodic standard function. Now we will choose the periodic standard waveform. Now it is a period of 1 millisecond. We will choose very small intervals, and this is a graph for that. And we can simply see the discrete time graph. And here's the code, which we will use the time period of 1 millisecond and simply use a sign. Now moving on to our next part, we will see signal addition, where first we use CLC and then we prompt the user for input, and we then declare vector t and exponential c vectors. Then using a variable, we add these 3 vectors to get our addition signal, and similarly we do for discrete time. Now we will run this, and here as you can see it is a prompting to give us starting range. Let's choose a small value, and yeah, now we can see the plot for that continuous and discrete. We'll see our last function, which is for signal multiplication. First we use CLC to clear the screen, then we prompt the user for input, and we similarly declare 2 vectors with the given frequencies, which is 125 Hz in this case and 1000 and the amplitude is 105, and we create these in 2 vectors and we simply multiply them element wise using the dot operator. And similarly we can do for the discrete time interval also. Now we will run this code and let's see. Now we will use a small starting value because it has very low time period and ending value, and we will see the plot here, which we get the plot here for signal multiplication, continuous time, discrete time. So this was the report on the second assignment of signal system laboratory. Thank you.